This is page 50 in our notes. We're continuing on with what was it, EE4 on equations and inequalities. We had already gone 3 examples. We're just going to continue on the next page. The sum of 5 and n is less than 20. So this paper should be glued or taped in your notes on page 50. So here's what they're telling us. Remember, the directions are we're supposed to use this to write an equation or inequality and then solve. So if you look at this, sum means that we are adding. We need to add 5 and n. They give us the keywords less than, so this tells us we're doing an inequality. If you remember, the less than sign looks like this, and then 20 is our number. So let's just write it. Sum means we're adding 5 and n, so you should have 5 plus n is less than, so you're using the less than sign, 20. So right there, you have written the inequality. That's part of the directions. Write the inequality. Now you need to solve. If you remember, in order to solve, you're going to use the letter n. That's our variable we're using. We're going to use the same sign that we have in the problem, same sign, and the problem to solve, same sign. So n is less than. Now, in order to solve this, we need to put a number in here for n that would make this exactly true. 5 plus what would make it exactly 20, would make it equal 20. 5 plus 15 would make this exactly 20. Okay, so why does this work that we say n has to be less than 15? Because we know if we put exactly 15 in, we're going to get 20. If we put in a number here for n that's less than 15, like for example 10 would be less than 15, then if I put in a 10 here, 5 plus 10 is 15, and that answer 15 would make this true. 15 would be less than 20. Let's try another example. The difference of t minus 8 is greater than 10. Difference, this is a keyword telling us to subtract. T minus 8 is what we're needing to subtract, is greater than, so we know we're writing an equality instead of an equation, because it's greater than means we're using the greater than sign, greater than 10. So we're ready to write. T minus 8 is greater than 10. So that's our inequality. We had to write the inequality. In order to solve for it, our variable is t, so we put a semicolon t. We use the same sign. So we use the greater than sign, same sign. Okay, so how do we know what our number is going to be for t? What would we put in here for t that when we subtract 8 would make it exactly 10, would make this true? If we put in 18 and subtract 8 would make it exactly 10. So 18 works. So you say t has to be greater than 18. So what's a number greater than 18? Let's try 20. If you put in 20 and you subtract 8, you're going to get 12. Is 12 greater than 10? Yes, so that's true. Another example here that we're going to do says the quotient, which means we're going to be dividing. S divided by 3 is less than 7. So less than, you're using the less than sign. This is an inequality, is less than 7. So S divided by 3 is less than 7. So there's the inequality. We've written our inequality. Now we need to solve. Our variable is s. We're going to use the same sign as we have here. The same sign as the less than sign. And then what number could we plug in for s that would make this exactly true? S, that when you divide it by 3, you're going to get 7. S would have to be 21. 21, when I divide it by 3, I would get exactly 7. So why does this work? I forgot to write same sign right here. Let's pick a number for s that's less than 21. For example, what if we picked 18 for s? 18 is less than 21, so if I do 18 divided by 3, I get 6. Is my answer 6 less than 7? Yes, so it is true. So that was writing inequalities and solving. So now the next set of directions we're going to do is just write inequalities. You can use the greater than sign, the less than sign, the greater than or equal to sign, or the less than or equal to sign. So here's our clue. This is going with standard EE 4 and 5, so I want to write that in here. These directions go with EE 4 and 5. And then in order to help, we're going to write the variable first. Write the variable first. And then that's important, so I want to make sure that we star this, box this in, put some stars here, right? The variable first. I want everybody to say it. So if you need to earn at least $50, we need to write a variable first. They don't tell us which variable to use, so we can choose one. Most of the time you just choose X because that's a common variable. And you know the number's $50. So you have to figure out which one of these signs would make this true. If you earn at least 50, you know it could equal it, but at least kind of sounds kind of different here. You could earn at least 50. Could you make more than it? Yes. So you have to say greater than or equal to. At least 50, meaning you could have 50, but you could actually have more, which sounds kind of strange because at least sounds like it should be less. But if you have at least $50, you could earn more. So this is writing your inequality. X is greater than or equal to $50. Let's try another one. You can spend no more than $5.60. We need to write the variable first. Do they give us one? No, so we can choose X. We know the amount is $5.60, so no more than that. So you can't have any more than that. Could it equal it? Yes, it just can't have any more. So it's, you know, it can equal to it. So if you can't have any more than that, you put the less than sign. X could be less than or equal to $5.60. You can spend no more than that. Like if that's how much money you have to go to the store with, then that's the most you could spend. You could spend less and then have some change in your pocket to take home, but you just couldn't spend more than that. So you would read that X is less than or equal to $5.60. The trip will take at least 4 hours. So we need to write the variable first. They don't give us a variable, so we could choose X. We know it's 4 hours. So what sign goes in here? At least 4 hours. Could it be 4? Yes. But at least means that's the least amount. It could be more than that. So you should have X is greater than or equal to 4 hours for your inequality. The at least is the same thing here, so we're using the same sign again. The car ride will be no more than 8 hours. So write the variable first. X. 8 hours. What are we putting here in the middle? No more than 8. Could it be 8? Yes, but you can't have any more. No more than 8. So it could take 7, it could take 6. No more than means you have the less than sign. No more than 8. 8 is the maximum amount of time it would take. So you have X is less than or equal to 8 hours. 4 boxes of candy contained at least 48 pieces total. So, and this one here, if you're writing an inequality, you have 4 boxes of candy on this side. It contained at least, there's that key word, 48 pieces total. So I have 4 boxes, and I know it's 48 total pieces. So what's my inequality? 4 boxes contained at least 48. You could have 48, but you could actually have more than 48. So this one doesn't actually have a variable because they gave you numbers on both sides, but you can still write the inequality. At least, you could have 48, but you could actually have more. With John's 7 marbles and mine, so there's a reason why I underlined both of these. 7 marbles and mine, that's like together, right? We had less than 20 marbles together. So together is a keyword telling us we're adding. So John's 7 marbles and mine, we had less than 20 marbles together. So John's 7 and mine, and is another keyword that like we're adding his and mine together. So we have 7 plus mine. So for mine, I could put M for my variable. We had less than 20. Less than, do you hear the sign? We had less than 20 marbles. So you add, because it says together, it also says and. Less than, because of the less than sign, or the word less than, 20 marbles. So that's your inequality. 7 buses can hold no more than 560 students. So I have 7 buses, and over here I've got 560 students. You have to figure out which sign goes there. No more than that. So could it equal that many? Yes, but it can't have any more, so you would say less than that. Your buses can't hold any more than that because there's no more seats, so that you can have less kids on there, or you can have exactly 560 kids. The next part of the instructions, you're going to see substitute the given value in the equation and then tell if the variable is a solution. You need to circle yes or no. So here's the example. Number 1, I'm going to write it. The example is n divided by 14 equals 7. And then over here, the parentheses say you need to let n equal 98. And then they're going to say, is this a solution, question mark, yes / no. Give you a chance to write that. So the directions are telling you to substitute the given value into the equation and then tell if this variable will make this a solution. In other words, is it going to be true? Circle yes or no. So when n equals 98, if I put 98 right here for n, and I take 98 and I divide by 14, 14, does that equal 7? If it does, then yes, it's a solution. If it doesn't, then no, it's not. And when I plug 98 divided by 14 in on my calculator, I get 7. So that makes it a solution. That's true. The next example, 27 equals 16 plus a. And then the parentheses say you need to let a equal 9. Is this a solution? Question mark. Circle yes or no. So here's your equation. They're saying that a is going to equal 9, so you need to try 9 in here for a. If I add 16 plus instead of a, I need to put a 9 in there. 16 plus 9 gives me 25. That is not equal to 27. So that is not a solution. So I would circle no.